Hello guys, you are welcome to this lecture. In this lecture, I'll be answering questions on the past question papers, preferably 2020. Now, the question say write short notes on glycerophospholipid and glycophospholipid. Now, if you watch the video on lipids, I classify lipids into phospholipids. That is under complex lipid. Phospholipids. Now we said the phospholipids are classified into two. We have the glycerophospholipids, and then we have glycophospholipids. Now let's write the short note on glycerophospholipids. Now we said glycerophospholipids are those lipids. Glycerophospholipids are lipids that have glycerol as their backbone. They have glycerol as their backbone, and the glycerol OH are esterified with the glycerol OH are esterified with fatty acid at carbon 1 and carbon 2, and also we said there is a phosphate group there's a phosphate group attached at carbon 3. So we can say glycerophospholipids are complex lipids. They are complex lipids that consist of fatty acid and glycerol as the backbone. And a phosphate group. They also have a phosphate group and then a nitrogenous base. Now we said the glycerophospholipids are classified into different types. We have what is called the triacyl glycerol, etc. Example of glycerophospholipid is phosphatidyl. We have the phosphatidic acid, example phosphatidic acid. We have phosphatidylcholine. If you watch the video on lipids, you will see all these things there. We have the phosphatidylserine, phosphatidylentanolamine, and phosphatidylinositol. All those on the example of glycerophospholipids. So we can say inositol and others, ethanolamine. So we can say that glycerophospholipids have glycerol as their backbone. That is the most important thing you must say. They have a phosphate group. Now, if you want to draw, they have a phosphate group that is actually esterified with a nitrogenous base. Now, what would you say is the form of glycerophospholipid? If you want to represent it, you now say this is COO. Then you have O. Then you have what? C double bond O and arrow prime. Then you have CHO, C double bond O, arrow prime prime. Then CH2. Then you have O. Then this one is phosphate group. Double bond O, O minus O, and then you have the nitrogenous base. This is the general form of all glycerophospholipid nitrogenous base, where this one can be serine, ethanolamine, etc. Is that understood? So that is basically all what you need to write under glycerophospholipid. They are phospholipid that have glycerol as their backbone, and they consist of fatty acid esterified with glycerol. They also have nitrogenous base and a phosphate group. Now, the backbone of all, or the simplest of all glycerophospholipid, is phosphatidic acid. Now, this is the structure of phosphatidic acid. Arrow prime, CH, there O, C double bond O, arrow prime prime, and then CH2, O, P double bond O, O minus, and this. This is the phosphatidic acid. Is the simplest of all glycerophospholipid, phosphatidic acid. So please take note of this. So when they ask what are glycerophospholipid, I believe you now have much to give, or much to say. Example is, we have the examples here: phosphatidic acid, phosphatidylcholine, phosphatidylserine, phosphatidylinisator, and ethanolamine. Now, talking about the glycophospholipids, they are phospholipids that contains, as name implies, glyco means glycophospholipid. As the name implies, it means they contain carbohydrates and phosphate group. They contain carbohydrate and phosphate group as structural components. Okay, that is what the glycophospholipids are. So that's the discussion you want to write. Now, when you are writing, there are not really much details about this glycophospholipid. So you write much on glycerophospholipid in order to compensate for glycophospholipid. They have carbohydrate and phosphate group as what? Structural components. They are called glycophospholipids. Is that okay? Or glycolipid. Now, if you talk about glycolipid, the backbone is sphingosine. Sphingosine is the backbone. Why for glycerophospholipid, what is the backbone? The backbone is glycerol. Why this one? The backbone is sphingosine. An example of this is we have cerebroside, we have ganglioside, etc. Okay, cerebroside, ganglioside, etc. So that is that for that first question. Let's go to the next. State any chemical property, any 4 chemical properties of monosaccharide. Write briefly on any one of the 2. Now, chemical properties of monosaccharide is 1. Enediol formation or enediol formation. Then we have 2. Reduction property. Reduction property. Are we getting a reduction reaction? Let's just put it as reduction reaction. Then number 3, you have oxidation reaction. Oxidation reaction. Then number 4, we have, I've named the oxazone formation. Oxazone formation. So all these are chemical properties of monosaccharides. Okay, so I'm going to talk about the reduction and oxidation reaction. They are both more easy to memorize. Now let's talk about oxidation reaction. Oxidation reaction. Oxidation in chemistry or in biochemistry means what? Either the addition of oxygen or the removal of hydrogen. Is that understood? So depending on the oxidizing agent used. Depending on the oxidizing agent used, we can oxidize the aldehyde group. Let's say this is the aldehyde functional group, or the alcohol functional group. Let's say the OH group of the carbohydrate, or the OH functional group of carbohydrate, to form the following product, to form oxidized product. Let's say to form oxidized product. Now the oxidized products mostly are acid, carboxylic acid. Now let us take glucose for instance. If this glucose, this one has this group, then it has C, this OH, H, C, OH, H, C, OH, H, then we have C, OH, H, and CH2OH. Now, if this aldehyde group is oxidized, let's assume this one is oxidized, what will be formed? It will form, let's say the aldehyde group is oxidized, that means this up is oxidized. It will form this, because when that group is oxidized and the group under is protected, it will form the following. Now this it formed is called gluconic acid. So this will form gluconic acid. So whenever they are oxidized, they form the acid derivative, okay? Gluconic acid. How about if it is this OH that is oxidized, CH2OH, instead of this group here? Now we say when this group is oxidized, we form gluconic acid. How about if it is this group that is oxidized? What will it form? Oxidation. Let's assume this group is the one oxidized, the one under. What will it form? It will form glucuronic acid, which is C double bond O. Oh, get out. H. Oh. And then COH. There you have this H. Here will be C, H, OH, and it continues down until it gets to this carbon. Let's assume this will become C. Instead of you to have CH2OH now, you are now going to have COOH. Now this product is called glucuronic acid. So when they are oxidized, if the aldehyde group is what is oxidized, it will give you gluconic acid. While if it is the group here, which is the terminal or the last alcohol group that is oxidized, it will give you glucuronic acid. Is that okay? So that is that for that. Now let's look at the next reaction, reduction reaction. Now if they are reduced, let's say you use sodium amalgam, a reducing agent, to form sodium amalgam, reducing agent. Let's say you use sodium amalgam as a reducing agent, this sodium amalgam. Now what is it going to form? Each of them will form different products in such a way that glucose, D-glucose, will form D-sorbitol, D-mannose will form D-mannitol. The spelling I'm not sure. D-ribose will form D-ribitol, and etc. Even D-galactose will form, I think this will form dositol, and then etc. So that is for the reducing and oxidizing. Oxidizing will form the acid, while reducing will form the what? The alcohol. to form the alcohol. All these ones, they are alcohol. Sorbitol, mannitol, ribitol, dositol, all those ones, they are what? Alcohol. Is that okay? Now, what do we mean by that reduction? For instance, glucose is C double bond O. You have something like this as glucose. Let us assume this is the structure, then down to you have CH2OH. I believe by now everybody should know how to draw glucose. Don't go and do like this in the exam. Draw the entire structure. Because of time, that's why I'm drawing this. Now, if it is reduced, let's say with sodium amalgam, what will it form? It will now form, instead of having this C, this aldehyde group here will be reduced. Now, if this aldehyde group is reduced, you form CH2OH, and then everything will continue down until you now form another COH under here. It continues down until this other group here. So it means that this aldehyde group is being reduced to what? Alcohol. Is that understood? Which will now form D-sorbitol. For mannose, D-mannitol. For ribose, D-ribitol. And for galactose, dositol. And even I think maltose, maltose on one of them, we give D-sorbitol and what? Mannitol. Okay, so that is that for this. Now, let us answer what are enzymes. Now, we can say that enzymes are organic catalysts. They are organic or biological catalysts. Biological catalysts that are proteinous in nature. Proteinous in nature. That speeds up the rate of a chemical reaction but is not used up at the end of the reaction. But they are not used up at the end of the reaction. So we can say that enzymes are biological or organic catalysts that are proteinous in nature, that speeds up the rate of a chemical reaction, but are not used up during the what? During the course of the reaction. That is what enzymes are. Now, I said outline any two features of enzymes. Now, one of the features of enzymes is that they are very specific in character or catalysis. One, they are specific in character. That means a particular enzyme can what? Is specific for, let's say, a particular reaction. Is that understood? They are specific in character. So that is one of the properties of or features of enzyme. Now, all enzymes are protein. All enzymes are protein. Everyone knows this. But not all proteins are enzymes. All enzymes are protein, but not all proteins are enzymes. Okay? So that is the answer to that question. Now, another thing is that they are very sensitive to heat. They are very sensitive to heat or temperature. Very sensitive to heat or temperature. They are heat labile. They are sensitive to heat or temperature. They are heat labile. Then another feature is that they all enzymes function in and leave that last one. These are the three I can remember. They are specific in character. If you can memorize that one, you can memorize it. They are specific in characters. All enzymes are protein, but not all proteins are enzymes. Then very sensitive to heat or temperature. Now the next question says, state 5 factors that affect enzyme catalyzed reaction. Now the factors that affect enzyme catalyzed reaction are pH, number 1, 2, temperature, Number 3, inhibitor slash activator concentration. Inhibitor slash activator concentration. Then we have 4, substrate concentration. Substrate concentration. And then 5 is enzyme concentration. So these are the 5 factors that affect enzyme catalyzed reaction. We have 1, the pH, 2, temperature, 3, inhibitor or activator concentration, 4, substrate concentration, and 5, enzyme concentration. Now, everyone knows what the substrate is. The substrate is what the enzyme is acting on. Okay, what the enzyme is acting on is what is called the substrate. Okay, so what the enzyme is acting on. So those are the 5 factors. Let's just go straight to each of the points. So the question say, what are enzymes? We define enzymes as organic catalysts, proteins in nature that speeds up the rate of a chemical reaction but are not used up during the end of the reaction. They are specific in character. All enzymes are protein, but not all proteins are what? Enzyme. They are very sensitive to heat or temperature, so we can say that they are heat labile. If something is we can say they are thermolabile. Something that is sensitive to heat is what? Thermolabile or heat labile. So that is that. Now the next question says, what do you understand by allosterism? Now, allosterism is a phenomenon whereby enzymes have allosterism is a phenomenon whereby enzymes have other binding sites apart from the active sites. Have other binding sites apart from the active site. That is what allosterism is all about. Now, this active site is called the specific binding site. So when it have other binding sites apart from the specific binding sites, we say such an enzyme or exhibit allosterism. Now, all enzymes that undergoes this are said to be allosteric enzymes. They are said to be what? Allosteric enzyme. And all regulatory enzymes are allosteric enzymes. All regulatory enzymes are allosteric. Okay, so that is what allosteric enzymes are, and they can act on more than one substrate. Allosteric enzymes can act on more than one substrate. Okay, one substrate. So that is all you need to know about allosteric enzymes. Now, let us identify and classify identify the main class of the enzyme whose enzyme commission number are given below. Now, the enzyme commission number, you can say O, T, H, L, I, L. Where O is the first one, means oxido, or you can say oxidase reductase. T means transferase. H means hydrolase. This L means lyase. I means Lysis. This is oxidoreductases. Can take it oxidoreductases. Lysis. I means isomerases. And then L means ligases. So all these are the classes. Now class 1, this class 1, this class 2, this class 3, this class 4, class 5, and class 6. So you see how easy it is. Just use OTHLIL. Are you getting it? Or over the hills. Over the hills. But you must take note of this L, that L comes before what? I. So coming here now, what kind of enzyme will you classify this to be? The first one, what would you classify it to be? Let's look at EC31320. Now the first class here is what determines the class to which it belongs. So this enzyme is hydrolase. Hydrolases. Are you getting it? Because it belongs to 3. Now this first one is 2 here. So you say this is what? Transferases. This one is class 1. So you say this is oxidoreductase. This 4. So you say this is what? Lyases. This 6. So you say this is what? Ligases. Ligase. And this 5. So you say this is what? Isomerase. So all these are the classes. Now, you just look at the first number here to pick your class. Like this one now, the first number here is 3. The first number here is what? 2. First number here is 1. First number here is 4, 6, and 5. So you now come back to this your what you wrote here and then choose the class: hydrolase, transferase, oxidoreductase, lyase, ligase, and what? Isomerase, using OTHLIL. So that is the major class of enzymes. Okay. Now the next, name 3 enzymes each for the clinical diagnosis of the condition of liver. Let's take liver first. What are the 3 enzymes? Now, talking about the ones found in the liver, you have the acid phosphatase, then you have the alanine amino transferase, then you have the aspartate, which is one of the amino acid, aspartate amino transferase. All these enzymes, they are used for clinical diagnosis of liver condition. Acid phosphatase, alanine amino transferase, aspartate amino transferase. These are the 3 enzymes that helps in clinical diagnosis of conditions of the liver. Now coming to the heart, the 3 enzymes that help for that. When acid phosphatase is for liver, base or alkaline phosphatase is for the heart. So we take it as alkaline phosphatase. This one is for heart. Then we also have gamma glutamine transferase. This one is also for the heart. And then we have the lactate dehydrogenase. This one is for the heart also. So these are the 3 enzymes each for clinical diagnosis of heart issues. Okay. Now, the factors that influence enzyme catalyzed reaction. We have the concentration. We've stated this before. This for 2019 now. Okay. We said we'll end in 2020. So these are the questions in 2020. I believe so. Is there any other one that we've not done? 5 factors that affect Okay, we are done with that. Now, electrophoresis. Please, let's go and read that one. The differences between DNA and protein electrophoresis. I've not gone through it, so let me not state what I really don't have much details about. Then this, we've done this. So that is that for this first session. I will talk about the one of 2019 now.